Macaulay's duration. So you can go through the calculation, but we're also going to discuss the concept of duration. Um, what duration is intended to do is to measure effective bond maturity. What it is the weighted average times of until each payment, um, with weights proportional to the present value of that payment. So what we're going to do is we calculate the present value of each payment, and then we divide it by the price of the bond or the present value of all payments. So the weight is simply the cash flow, the, the, uh, the present value of the cash flow, which is cash flow divided by 1 plus y to the t. So, for example, um, a if we're calculating for a cash flow that occurred in 4 years, um, for a semi-annual bond, it would be 1 plus the yield divided by 2 uh, to the eighth power. I think it would be 4 times 2, and then that would be divided by the bond price. The duration is simply the sum of t times the weight. So so t would be every period. So that would be for the example before, it would be one through 8. So it would be 1 times the first weight, 2 times the second weight, on down the line, 8 times the very last weight. This is an example. It's a spreadsheet and shows a calculation of duration. We have our 8% coupon bond. Time to maturity is 3 years. So it's the current interest rate is 10%. So so this is 80 divided by 1.1. The second payment is 80 divided by, the present value is 80 divided by 1.1 squared. And then we have the return of the principal, so we get $1,080. Divide that by 1.1 cubed, and we get the $811.42. Add those up, and we get the price of the bond. So the first weight is 72.727 divided by 950, that's 0.0765. And then 66.116 divided by 950.263, that's 0.0696. And then 811.42 divided by the 950.263, and that gives us 0.85239. So now we calculate the duration for each individual payment. So that's 1 times 0.0765, then 2 times 0.0696, that's 0.01392, and 3 times 0.8539, that's 2.5617. Add those up, and we get a duration of 2.774. Down here below, we see that the duration of a zero coupon bond is a 3-year zero coupon bond is 3 years. It doesn't matter what the yield is, because the only cash flow that occurs is exactly 3 years from now. So down below we have the formulas for that you would use if you were creating a spreadsheet in Excel to calculate duration. There is also a function in Excel that will calculate both Macaulay's duration and modified duration. So interest rate risk, change in bond price to yield to maturity. So it's how quickly does what's the level of change related to a change in maturity. So we can use duration to approximate that calculation. So it's just the change in price divided by price. So the change in the price is equal to minus duration, because yields and prices are inversely related, multiplied by the change in yield. Um, this the delta y, or the change in y, is the same as the change in 1 plus y, so this is unnecessary. So just the change in yield divided by 1 plus y, and that will give us an approximation for the change in price. The smaller the change, the smaller the change in yield, the more accurate the calculation is, and we'll see that on a future chart. But we can use duration to accurately predict changes in price, um, small changes in prices for small changes in yield. Modified duration is simply Macaulay's duration, or we use D star to denote modified duration. It's simply Macaulay's duration divided by 1 plus y. So if we're going to calculate the change in price using modified duration, just minus D star divided by the change in yield, because since we have we're dividing by 1 plus y, this cancels out the bottom portion of this fraction. This is what I mentioned before. This is just an example. This is an Excel spreadsheet, or picture of an Excel spreadsheet that uses the duration and modified duration function. Welcome to play with these if you like. There are some, if you have access to Connect, McGraw-Hill Connect, there are some spreadsheets that you could use if you do have that access. So what determines duration? We talked about some of these at the beginning of the chapter. Zero coupon bond is its time to maturity. So a 10-year zero coupon bond has a duration of 10 years. So whatever that maturity is, we saw the 3-year had a duration of 3 years. So that doesn't change. If we hold time and maturity constant, bond's duration and interest rate sensitivity are higher when a coupon is lower. Hopefully this makes sense. The most sensitive instrument we looked at previously was the zero coupon bond, but also when we looked at the interest rate sensitivity, bonds with low coupons were more sensitive to price to yield changes than were the bonds with high coupons. That's because the intermediate cash flows are lower. Coupon rate constant, bond duration, and interest rate sensitivity generally increase with time to maturity. That should make sense. The longer a bond is outstanding, the longer time you have to discount those cash flows. Bond's duration also increases with maturity for bonds at or above par. So what determines duration? Other factors held constant: duration and interest rate sensitivity of a coupon bond is higher when the bond's yield to maturity is lower. We saw that in the chart. I think it was slide 4 or 5 in this chapter. Duration of a perpetuity. This is important. You'll need this for your homework. Duration of a perpetuity is just 1 plus the yield divided by the yield. So simple calculation. We'll use perpetuities for our immunization strategies in the homework and on the exam. So figure 11.1.2 just shows duration as a function of maturity. We start at the top here. We see that the zero coupon bond, it's a linear relationship. The 5-year zero coupon bond has a duration of 5 years. A 30-year zero coupon bond has a duration of 30 years. And if we look at these others, we have a 15% coupon bond with yield to maturity of 6%. We have a 3% coupon bond with a high yield to maturity. See that duration is lower the further we go out, and but it's also higher than a higher coupon bond. So this 15% coupon bond with a 15% yield maturity is going to have a lower duration. We're going to have more cash flows in the intermediate period before the bonds mature.